Okay, we're live. Hi, everyone. Welcome to the
Hi.
July OWASP Toronto meetup. We have with us Paulo Swavely from Contrast Security and myself and Adam just doing the background emceeing for the event. You wanna have anything that you wanted to talk about, Adam, from a like announcements perspective or whatnot? 'Cause-
Oh yeah, I mean from an announcements perspective, if you have any questions or comments, feel free to leave that in the box. We'll be periodically checking that and asking that to our speaker. If you're looking for CPE credits or you have feedback for us, there's a link in the description of this video. Feel free to fill that out. And if you're looking for work or you're hiring, please drop that in the chat as well, and you guys can coordinate.
Welcome, Paul. Um, Okay, so what we're probably going to
Thank
do
you.
is give people another 4 or 5 minutes to kind of trickle in. And in the meantime, we'll just have a little bit of a chat. Before we came on the stream, we were asking Paulo like where you had been before he joined Contrast and kind of like what he was doing these days, because I think he just switched over into Contrast. What was it, seven? You were saying a couple months ago.
7 months.
So 7 months ago. Okay. Thank you. So like, yeah, so I guess to resume then, like, what do you do, what is your job function at like Contrast these days? Because you were saying your profile does say that you're like a cloud security researcher, and this you were saying you were focusing on serverless, but like that is so many things in terms of scope. So
Yeah, it's a quite broad scope. At the moment, I'm mainly focusing on serverless and
mm,
serverless attacks on serverless application and serverless architecture. Normally, in my day-to-day work, I pick up an attack from one of the many that there are in the OWASP list or in the classical environment and see what we can achieve in a serverless environment that is a different environment than um, the one that we are used to. And I also support the contrast sales and contrast professional services to support them and support the customers that are using our products. I'm working on the obviously, if I don't know if you are familiar with the contrast platform, but we have a serverless product and that is able to scan um, AWS Lambdas and very soon also Azure functions. So I support our customers on, on that product.
nice.
And I'm also sometimes I also do some sort of security guy for our development team, supporting them if they have any question or any concern about security of the product itself.
Makes total sense. Yeah. So you end up
Uh,
being, so you end up being like the security, the oh, you do security, right? Come into this call and talk about X.
Sorry, say it again.
I said uh, you probably end up doing the whole like people understand that you do some part of security, so they come to you for everything. Like, come onto this call, talk about this, and you're like, that isn't even remotely connected to what I do, but cool, I'll give it a shot.
Yeah. And if you are interested on what I have done previously, I started my career as a developer, as a web developer. I built application in Java for more than 5 years, and in a company in Florence. I'm from Florence in Italy.
Nice.
The company was controlled by General Electric many years ago. And then So I was so in my role, I was already doing a lot of stuff from an application security perspective, and the security team in the company itself asked me to move to the dark side of the moon, and I accepted. And so I started my journey in security, and especially in application security. Then after a while, GE started the journey on AWS, on migrating many applications to AWS. If you had the opportunity to listen and Jesse at their event, I think he mentioned it almost every year that GE in a few months migrated a lot of application to AWS, and I was part of the team.
Mm.
And then I started working on cloud security, doing a lot of security automation, compliance as code, infrastructure as code, all these things. And recently I joined.
Joint contrast.
Yeah.
Nice. Great. Hi, Paul. Welcome. I think we added you to the stream when you were not sure if you were quite ready. So thank you for that. Do you want to like? I know you're not one of the key speakers necessarily, but do you want to quickly introduce yourself as well?
Yeah, sure. Thank you. So I'm Paul Kaiser. I'm based here in Toronto. I'm the regional sales manager, one of the regional sales managers up here, focused on large enterprise accounts, and have been working with Contrast now for 2.5 years.
Nice. Are you here just to observe?
I'm sorry?
Were you here just to observe, or did you want to, or
Yeah.
you're going to speak too?
No, anytime Paolo is talking, I always try to take an opportunity, especially in the Canadian context. So I just sit down and listen in, and if I get any questions later, I'll know what the context was, so to speak.
Absolutely, makes total sense. Okay, well, thank you. I don't want to take up any more time necessarily. I think I made admin go through the housekeeping earlier. So if you are in the audience and you missed it, there's a feedback form in the description of this talk, which we do read, and we want to know what you think about these different things, and also like any content that you're looking to hear about. If you need CPE credits, and then we encourage you to please use the feedback form to leave your actual name and a contact information, so like an email address, because if they ever come back and say, was this person here at this event, we will need something about that. So aside from that, I think we're good. So I think I'm just going to hand over the thing to Paulo and let him go ahead with his talk. He has agreed to answer questions throughout the talk as well. So please keep it interactive. Feel free to ping things into chat, and we'll put them up on the YouTube video and interrupt Paulo to ask the question. Okay, awesome. Thanks.
Can
Go
you
ahead.
can you see my screen?
Yep.
Yep.
It's not yet on presenter mode though. Yep. Perfect.
Okay. So I already introduced myself. So if here you can see my contacts. So if you will be interested on the content of the call, so feel free of the presentation. Feel free to reach out to me for any question you may have. So first of all, thanks everyone for joining. I'm happy to be present to present at an OWASP event. So OWASP has been my guidance for many years. So it's quite cool for me to be here. So let's start. So let's start with a brief introduction on what is serverless and serverless security and the challenges that we have in this environment. So why serverless security? Because it's going to be the future of application development for many firms. And if you read on the internet, everything is on cloud and cloud native. Forrester preview that 25% of developers will use are using already serverless regularly. So 1 out of 4 developers already use everyday serverless technologies. And so in this event, if you join, probably even more than 25%. So what is sorry? Okay. So this is a serverless application, serverless architecture that we are monitoring at Contrast. Not so big, but if you can see, there are a lot of resources. The purple one are API gateway, so API endpoints. The orange one are lambdas, and the green are buckets, S3 bucket, etc. So there are a lot of resources in a serverless application. And so serverless applications are relatively easy to start with. Okay, so it's easy for a developer to start building a serverless application, start writing code in a serverless environment. So if you're using AWS, you go in the console, there is a Cloud9, and start typing code and deploy. It's pretty straightforward. But the challenge here is also that when things start being more serious, developers should not forget to follow architectural principles and good programming principle, etc. So this sometimes happen when things are easy to do and easy to deploy and easy to release. Sometimes we can lose focus on good practices. Serverless a service application is hostless, so you don't have to deal with server anymore. It's managed by the cloud provider, and it's a good thing. It's a nice thing that many developers really like it. The challenge here, also from a security perspective, is the misconception that serverless means secure by default, because you don't have a server, you don't have to patch, or the cloud provider will patch for me, and it's a quite dangerous assumption to do. So you also have to do some work also in a serverless environment, in an hostless application. So, and we will see later in the presentation. Is stateless by default, and so there is no state. It's not a stateful application. You have many components, as you can see in the picture, and there is the management of authentication and authorization. It's different than the classical monolith application. Another trait of a serverless architecture is elasticity. So this is obviously by default. You can scale horizontally with ease. So it's for free. Basically, you don't have to do too many work to get your application scale. But you need to pay attention on cost. So if someone attack your application with a denial of service, and you don't have any limitation, you don't have any configuration that limit the number of runs of your lambdas, for example, you can have what we call denial of wallet. So you have, as you pay for execution, if you have 1 million of execution, you are going to pay money, and maybe you are going in trouble from that perspective. Number 5 is distributed, obviously, and the picture is pretty clear. So you have a lot of loosely coupled components that are talking each other and are building some kind of a logic of your application that maybe, I don't know, it can be a simple chatbot, or can be a financial big application, or can be Netflix, and so it's a distributed system, and sometimes from a security perspective it can be difficult identify which are the real risk, because you have many flows, you don't have a single flow, you have many components, each component do a small piece of logic, so sometimes it's difficult to prioritize and identify which are the big risk in an environment like this. And then number 6 is obviously it's an event-driven system. So, and sometimes it's also difficult to troubleshoot the application or follow the flow of the system. So, as I was saying, it's an event-driven architecture. So you have a set of services that can trigger your function, that can trigger via some events your Lambda function. So the container spins up when it's triggered with everything inside, so or your packages or your dependencies and also your code. And when we are talking about your code, it may happen that we introduce some mistakes, and especially we are focused here on security mistakes. Your function also interact with a multitude of cloud services. It can be pretty everything, basically, because functions as a service are used for building application, but are also used as a glue of processes, or many, to make an example, ingestion processes. They can talk with databases, they can talk with IoT, and a multitude of services. So, which are the security aspects we should look at in a function in an AWS Lambda, for example? So, first of all, it's a read-only environment. Okay, so except for /tmp, the file system is read-only. You can write only on /tmp directory. It's not wired to the internet in the sense that you cannot connect to the environment. You cannot SSH to the runtime, but obviously it's connected. It have connection to internet. You can make HTTP calls. You can call API. You can call a third-party application. In some cases, you cannot, because you may be connected to your VPC, and you don't have the VPC is not allowing external connection. But in general, AWS Lambdas, or also in Azure functions, you have full connection to internet. Data is temporary, so at the end of the execution, the container is shut down, so you lose everything. And as the environment is spinned up and turned down is on demand. So at the end of the execution, all your data will disappear. There is an asterisk here because in case you have a call right after a previous call finish, for performance reason, the cloud providers leave the environment there. So you are the second call will use the previous container. This is called warm start. So it means the function is warm. The environment is up and running, and if you have many subsequent calls, they will share the same container, the same environment, and this may have some security issues, as we will discuss later. Also, your code resides in the environment. So when AWS or Azure spin up your container, they will the system will put, as I was saying before, all your dependencies and also your code in the container. So you have your source code in the environment as well. So it's not as we may think in GitHub and nobody can touch it. Here it may happen that someone can access your code. The keys that AWS, for example, create to have your lambdas able to talk with other AWS services are available as environment variables. So you have the keys, the key ID, the key secret, the access token, and other variables in the environment, and these sometimes can bring to some risk. So let's move to the OWASP top 10, serverless top 10. So let's start with the project. So it's the project is an interpretation of the OWASP top 10 in the serverless environment. You have the link here. We have a few data. So this is the link to submit the data. We will be more than happy to receive more data so that we can have more possibility to investigate, to analyze, and because our goal is to have a serverless tailored top 10. At the moment, it's just an interpretation. Following few data, we would like to have much more. So we will be more than happy to receive data about serverless. So let's start. So the first point is obviously event injection. So in the serverless environment, you may have multiple uncontrolled entry points, as you have seen before with the event-driven architecture slide. So your code can be triggered by multiple type of events. So you may have multiple entry points. You can have traditional injections like common injection, SQL injection, etc. You have as these function as a service are supporting multiple languages. You can have per language code injection. So you can have, for example, common injection in Python or in JavaScript, other type of SQL injection. It's a classical other injection. And you also may have new injections. So you can have MQTT, email, publisher and subscriber injection, etc. We will see some of them. We'll discuss about some of them. And the impact depends on the function permission. So in AWS, on the IAM policy, on the execution role that you assign to the Lambda. So the more permissive the permission are, and the impact is higher and the risk is higher. So here I made a list of injection entry point that you may have in AWS. You may have the REST APIs. I think it's the most used entry point. So in AWS you can trigger a Lambda when you receive a request on an API gateway. You may have HTTP request and REST. So pure HTTP and also REST-based API on the API gateway. Both of them can trigger a Lambda and So it's the most widely used, I think. You also have third-party application, cloud storage, S3, and others. Authentication services like Cognito, the native one, but also other third-party authentication services, logs, events, IoT, also the voice with Alexa, email with simple email service, SNS, that is the notification service, and also the code pipeline. So you can have a Lambda that is triggered as part of your deployment pipeline. So here I put a small demo of small research I made recently about the Spring framework expression language vulnerability that has been disclosed some months ago. So basically the vulnerability. This is not the famous Spring for Shell. It's a different one, but it's still an important one because it's on the Spring Cloud and on the Spring expression language. Basically, you can deploy your Spring Cloud application on AWS Lambda in a function in AWS. You can have an API gateway with a pure HTTP type of API that send an event to AWS Lambda and invoke the function. So Spring uses its expression language to manage the routing through a specific header. And if you have a Spring function with many methods in your controller, you can use this parameter spring.cloud.function.routing expression to redirect the request to the right controller. So the CVE was allowing a remote code execution using a bug in the Spring expression language. So I hope you can correctly see the video. So here I have Postman that is making a post request to the API gateway. This is the parameter.
It's a tiny bit small, Paulo. Is there a possibility to like zoom in?
I zoom in full screen. Let's see if I...
Yeah, it's a little more difficult to kind of like see. I guess it's readable. Okay, so keep going.
Okay,
Thanks.
thank you. So here is the payload I prepare. Below it's a tunnel that I open it to receive the data that I exfiltrate from the lab. So as you can see, so this is the event. So it's the payload, sorry. I basically open a socket to this IP on this port, and I print in the output stream the environment variable AWS session token. So here I open the tunnel that is listening on that port, on that IP and that port, and if I fire the request, I receive back the AWS session token. So this basically allow me to have a sort of non-interactive shell inside the container of the Lambda. I was able to run whatever command I want. It was just enough to translate the command in a Java expression following the Spring expression language notation. And a colleague of mine also built a small code to make the shell interactive instead of using Postman. So I don't know if there are any question. In case, let me know. But which are the best practice for event injection? So obviously, never trust, pass, or make any assumption regarding the input and the validity from any resource. So you always have to validate your input, and you have to consider all event types and entry points that you may have in the system. Okay, so based on the triggers that you have for your function, you have to double check that the inputs are valid and legit. You can use a positive input validation when possible. API gateway allow to configure some models for requests in the integration part of it. And obviously run the function with the least privilege required to perform the task. So basically you have to allow in your execution role only the actions that your code is using. This is to reduce the impact and the attack surface of an event possible attack. So if there are any questions, I can stop for a moment, or I can go with the next one. Okay, in case we can go back. Second, in the list is broken authentication. So, and this is mainly because of the fact that the functions are stateless. Okay, so it's a different way to manage authentication and authorization in respect of the classical way of the stateful. In my previous job, I found a lot of cases in which the developer was thinking that everything was fine, following the stateful way of authenticate a user, and then the application was stateless, and they have basically a lot of backend APIs completely open and not authenticated or nor authorized. So you may have multiple entry points, services, and events, type of events. So you need to pay attention to all of these and make sure that you are doing your best here. And you also, another challenge is that you don't have a continuous flow. So you may have a Lambda in your system that is triggered by an upload in an S3 bucket. And so you may lose focus on that Lambda, because as I was saying before, functions are also used as a glue between different processes and help building logic in a serverless environment. In general, so you have to pay attention to authenticate and authorize the functions, and so basically follow the zero trust principle in this case. So here is an example of what can be a broken authentication. So you have a Lambda function here that is mainly probably secure by itself because it's not exposed publicly. It have least privilege permission, so everything is okay, but it's triggered by simple email service, so that is public. So if an attacker is able to send malicious email in the correct form, maybe doing some experiment if it's public, and at the end is able to find the right format, the right way, it can trigger the function. So even if the function is protected and everything is okay, an attacker is maybe able to trigger your function run your code. And in this case, for example, it can approve a pull request on your behalf, so, or on behalf of someone else. So this is an example of broken authentication, and so that's why I was saying we should follow the zero trust approach here. So as a best practices, use authentication service whenever possible. You can use native ones. You can use also external ones like Okta or whatever it is. Access token in the JWT can include custom data that you can sign and you can use to perform additional validations. Obviously run as least privilege, and if necessary, you can store the state in a database or somewhere else. Is not commonly used. It's not a best practice, but if necessary, you can build your own state and your own session management. Any questions so far? Let's see. Any questions? Okay.
No questions so far. It looks like from the audience. Do you want to keep going, and then maybe the audience can think through what other questions, comments, suggestions they might have, and then I'll interrupt you if they come up with anything.
Okay.
Thanks.
Thank you. So number 3, sensitive data exposure. So here is the same than any other cloud-based data. So you have to follow the same principle. In a serverless scenario, you need to pay attention to four things. So you may have data under /tmp folder. So in case of the warm start we were talking before, the subsequent call can share the same /tmp, and maybe the two calls are coming from two different customers. You have sensitive data in environment variable. You may have sensitive data in an open bucket, for example, and also you have the source code in the environment in the container that the cloud provider spin up for running your function. So what we can do to mitigate this risk? So whenever possible, delete /tmp after use. Use KMS in AWS, or I don't remember the name of the same service in Azure. So in any key management system to encrypt the environment variable and sensitive data. In AWS, you can use also secret manager, or also parameter store. You can store also secure string in parameter store. Secure your bucket configuration for the data that you store in the object storage, and you may read from the function. Run as least privilege to reduce access to the sensitive data, obviously. And AWS provide also a service like AWS Messi to identify sensitive data in your environment. I think at the moment it supports all the S3 buckets, but it's worth to give a look at the capabilities of that service. So overprivileged function. So we talk about it in all the points. It's a very important point in a serverless environment. Capital One breach happened for an overprivileged. I don't remember if it was a function or instance profile or an EC2, but however, it was an IAM policy pretty open and not this privilege. So why we have this risk? Because it's not an easy thing. It's tough to make least privilege with IAM functions. So IAM is not easy service to understand how it works. So we estimate that more than 90% of the functions and IAM policy are misconfigured. And it have an important role in the impact that you may have in your environment if an attacker is able to exploit some vulnerabilities in your serverless application. So if your application is running, if your Lambda is running with the least privilege, you can limit a lot the risk, and in many cases the impact is not so big. But in extreme cases, you can arrive to have a full cloud account takeover. So it's something, things will get serious at that point. So here I have put an example. So one click. Okay. So here I put a piece of code that is creating the AWS S3 from AWS SDK. Is preparing the params and is reading the file from, is getting the object from the S3 bucket and is creating a file in a /tmp file.jpg in the container of the function. So here you can see what many times we found in the execution role of the Lambda. So we are allowing, so the effect is allow. We are allowing all the actions possible on S3 on all the buckets. So in the resource we have wildcard here. So the first correction that we see and we can do is limiting to only my bucket, still allowing all the action, but this is not enough because your code is just using get object. So you don't need to allow actions like put object that allow uploading object to the bucket, or modifying the ACL of the bucket, modifying the policy, etc. So you should reach least privilege using just the function and only the functions, the API call in AWS SDK that you're using in the code, and limiting with the right resource the access. So in this way, you can shut down the risk and the impact of a potential attack in your function. So the best practice here, it's obviously to review each resource and apply least privilege. Again, this is not easy at all. It can be feasible manually with 1, 2, 3, 5 functions. 10 if you are a very thorough guy or developer that look at each function manually. My suggestion is to automate this part in your application using your own automation, or leveraging an existing commercial tool or an open source tool, whatever it is. Because when you have, if you remember the first slide with the diagram of the serverless application, when you have hundreds or thousands of resources of lambdas, it's impossible to make least privilege know the functions. Also because the functions code change quite often, so it's not possible to keep the pace. So you need to have something that help you doing this work. Next, vulnerable dependencies. This is something that we have in the classical environment. We have also here. This is connected at the beginning when I was mentioning that the fact that it's serverless and we don't have a server to patch, it doesn't mean we don't need to pay attention to dependencies. We may have our function, our code may use an insecure dependency. It's a very common issue. Log4Shell is the most recent, most important example. When you import something, a package, that package bring with itself a lot of other packages. I put here this image of Python request. As you can see, there are many other packages that are imported, and maybe some of them are the next log4j. So you should pay attention to it. Even if your function, it's a small function, if you import request, you import all these packages. So you need to have something that check this. So you should scan your dependency as a best practice before deploying to production. You can use an open source or third party. There are many tools. I think there's a tool provided also by OWASP. And use secure versions of library. If you don't have a secure version of the library, try to find another one. It's normally you have multiple choices for the same scope. So like for creating PDF, you have many applications. To make HTTP calls, you have many libraries, etc. What else? Last but not least, insufficient logging and monitoring. So this, based on my experience, it's a very important thing, and it's a very huge challenge in cloud and serverless environment. So it's doing monitoring of your application is much more difficult than traditional web application. First of all, because you have many resources and you don't have a monolith. Okay, you don't have a server to monitor. You have many resources. Each one of these resources are sending logs to the native service, for example, CloudWatch. We don't own the infrastructure. So this is what I was just saying. So you don't have a server on which you can collect the logs, and you know that logs are coming from there. So each function is sending his logs. These logs can be very huge. Can produce. You may have gigabytes of logs, and you need to know what to extract from the logs and how to extract from the logs. And it's not easy. It's not an easy task to do. And also with such a huge amount of data, how you can learn, how you can see something. Okay, so you may have an application that every day produce 10, 20 or more gigabytes of logs in CloudWatch, and they are all divided by functions, so you can ingest into, I don't know, something like Elasticsearch or things of this nature. So you have to do a lot of work to monitor your application. It's not easy. And even if you're able to centralize everything in one place, when you have such amount of data, it's not easy to learn. It's not easy to find something in there. So it's a real challenge. that we have today, and so we there are some tools that commercial tools. I think there is something also open that may help you building centralize all these logs into one place and work on it. But so it's something important to look at. So there are other risk or vulnerability to discuss. I will go through over them quickly. So open resources is mainly misconfiguration. So you may have an open bucket that or some other open resources on the public internet that can be exploited by attackers. A Kubernetes cluster, classical example, or I found many also spinned up with the default configuration, maybe for running a small POC or test, and then leave it there running, and maybe an attacker can exploit them, an open bucket misconfigured. There are many cases. So here again, we should look at the configuration. There are many tools, commercial and open and free, for looking at the configuration of your resources in the cloud. If you're using infrastructure as code, there are also tools to scan your infrastructure, your code of the infrastructure. Denial of wallet and denial of service. Denial of service, I think you all know. Here there is a debate, okay, because if you don't put any limitation to your application on scaling, the application will scale infinitely, and if you have a denial of service attack, it will absorb, but with a cost, okay, that maybe can be huge, very huge. So, and then you have a denial of wallet. So you need to find the right compromise and the right configuration in your application between the limits and that you put on your application to between the denial of wallet and denial of service. Insecure shell space is what I was mentioning before. So if you have a warm start in your function, the environment is shared, and maybe the two calls are from two different customers, and it may happen that you can mix the data between customers, or an attacker is able to read the data from of another customer. Then last but not least, insecure secret management. So you may have some secrets stored in the code, and the code gets deployed in the container, is in the environment. It can be in the environment variable, so the suggestion is to always encrypt the secrets and the sensitive data. This is it. I want to show you another demo that has not been done by me, has been done by my manager some time ago, but I think it's good to show you to show what can happen in also in a serverless environment. So suppose you have a user that is interacting with a Slack chatbot, and this Slack API are configured to call the API gateway of the organization. So the API gateway trigger the chatbot Lambda that prepare the response, save all the data to DynamoDB, and return the response to the Slack API, and then to the channel. So let's suppose here that you, as an attacker, we already know that this Lambda, it's using a vulnerable library, vulnerable from two common injection vulnerability. Okay, this may happen doing some experiments, testing, etc. Also from GitHub, you can see. So this is the below in the dark console. You can see a tunnel done with ngrok, and the attack ran the child process and ran a command using a set of variables split up to avoid Slack to recognize that I'm calling ccarl with an HTTP URL composed by 3 variables. Okay, I run the /test endpoint. And as you can see, I received the request, okay, in my tunnel, in my laptop, in the laptop. Now I change, doing an ls, and I get index.js. Okay, so it ran a command on the file system, and it get index.js, that is the main, the standard entry point of Lambda done with developed with Node.js. So what I do now is I do a cut of the index.js. So I print the source code, and I convert to base64 to get it in one row. So I receive the base64 string. So I go to the web interface of ngrok. As you can see, there is the base64 version of the Lambda code. I go in my laptop and I decode the string, and I get the source code. And now it's in my laptop, and I can study the code. I can look at it, and I can see what it does. And looking at it, I see that it obviously interacts with slack.com. I was already aware, but now I know how it does. And here I can also see that some tokens are used, getting the value from the environment, bot_token. There is also username environment variable. And most important is interacting with DynamoDB. In the line above, I can see it requires AWS SDK. So the code is using Node AWS SDK, using a put item to save the data into the database. I also have the environment variable with the DB table. So I prepare a payload like this, where I require AWS SDK and HTTPS to be sure I have that packages available. I do a scan of the DynamoDB table, which name I have available in the environment variable. And I also send back to Slack using the same code that I saw in the code. So I can close the terminal, and I can run the payload. So, and as you can see, I get as a response all the values that are in the database, in the DynamoDB table. So, as you can see, this is another injection attack. It's really nice. You also can do attacks with Alexa, with voice. So if you search on internet, on YouTube, you can find something. So you can look at it. It's very nice. See an attack going on using your voice. Sorry. So this is it. I just a few more words. This is the way on which we propose to do at Contrast with our product Contrast Serverless. So basically, we deploy in a seamless way with a full automated onboarding an agent in your environment. The agent do a discovery of all the resources that are in your account, in your environment. It analyzes all these resources it analyzes the code statically. It looks at the weaknesses, the attack surface, the flows, etc., and generate and execute curated, dedicated attacks on your function and to test them in isolation. It as is inside, it can validate that the attack and the exploit is real exploit. So we are able to produce a very low quantity of false positive. And in addition to report, we continuously monitor the environment for changes and drifts. So every time a developer change the code, we automatically run the scan.
Nice. Thanks, Con. Thanks.
Okay. So last slide, it's to tell to the audience that we release a free tool called CodeSec to run scans for free on your Lambda functions. You can get the result in less than 1 minute. You can download the link here. So it's free to use, and we will be more than happy again to get feedback from all of you. That's it.
Awesome. Thank you, Paulo.
Thanks a lot.
That was awesome. It was very thorough. Where, out of curiosity, where are you getting like the numbers in your deck? Because I noticed something like 90% of like serverless functions are misconfigured in terms of like access and things like that. So a lot of like numbers in there. I'm always interested in where you're.
It's so it's an estimation on what we see from our customers. So and also we get data also from some surveys that our internal teams does in the market, in the community. But mainly is from what we see in our systems. So when we work with the customers, when we run the first time the static scan, we immediately found some IAM policy that are not misprivileged.
Neat. Okay, thanks. That's a useful. I'm always looking for more like studies that we can use to help clients kind of, focus in on some of the areas that are of interest. So always fascinated by this, like by these data sources. You mentioned a couple of vulnerabilities in some of your. I'm gonna like ask the questions that I had in my mind while you were going through the presentation while we're waiting for some of the viewers if they want to ask anything. But you mentioned like quite a few of these like vulnerabilities that are not necessarily part of the serverless top 10, but that you're seeing. in your research, like what are some of the like interesting ones that you've really that you've been researching or seeing that you found to be interesting and maybe like applicable to people in the audience, you think, that are maybe not part of the serverless top 10, for example?
Well, the main so recently, for example, I do research on XXE, XML external entity.
Hmm.
That is not so common. Okay, so as of today, because for example, based on the research I've done, uh, today is not easy to do the out of bound exfiltration of the data. Okay, because today the library, the dependency that do the HTTP call have fixed
Mm.
the issue. Okay, to make the call on an external site. But however, um, there are, and also if you search on internet, you can find something. There are cases in which the Lambda is used for ingestion or transformation of data. For example, all the data warehouse data that maybe an enterprise or a company have an old system that export in XML, or also a recent one, because XML is still used in some fields. And maybe they want to ingest into a Redshift or DynamoDB, so they need to convert XML to JSON.
Mm.
Or also you may have a stream from Kinesis in XML that goes to a Lambda, convert in JSON, and then go to a database. So in that Lambdas, you may have a vulnerability like XXC. So because maybe you are not able, the attacker is not able to exfiltrate, but maybe can create some damage or can put in your DynamoDB some wrong data or some scripts for later attack, so second order attack, etc. So this is one example of a recent research I made. Then the main attacks are obviously the injections, so that are done with the events, because the functions and the environment is event driven. So event injections is something that developers should pay attention and do validation of the inputs, etc. Because I mean, it's the environment. It's as I was saying in the beginning, it's easy to deal with. So you go and you start developing, and then you forget about validation, etc. So you leave it there. It goes in production. It happens many times. So
All the time, yeah. I agree. Okay. Like in your research, do you like a favorite, like a favorite vulnerability that you've researched, or if like a favorite case that you have seen that you like are able to talk about?
no.
No?
Everything that I would like to run SSRF from a Lambda to an EC2, but I'm not there yet.
Not there? Ah, okay.
But I mean, everything. So I'm really passionate about it. So everything it's good. It's nice for me. So, and actually, if someone have some ideas or some suggestions, so I will be happy to collect them and do some research about it.
Okay, so looking for collaborators who are interested in finding server-side request forgery in in cloud serverless functions. So if you're in that space, connect with Paulo.
Yeah.
Awesome. Yeah, that would be fun. I think that would be really super. Um, Okay. Any like predictions for serverless security? You're in the space. You're probably listening to what's going on there. Like, what's your thought?
Well, it's in my opinion, it's a pretty young field. Let me say, there are not so many companies paying attention to it. Mainly, so we start having a lot, I think a good amount of application that are running on a serverless environment.
Hmm.
Also, not only in AWS, also in other cloud providers. But the security of that environment is still not so much in trends, in my opinion, mainly because the word, the serverless word means people keep think it's secure. Okay, so because there are many, so it's first of all difficult to understand, in my opinion, because when you work at many years in on-premise, in a classical environment, it's not easy to understand what's going on in AWS. Okay, you think it's like an on-prem on a data center on steroids on the cloud. So also the first transformation that I've been part of was a set of EC2 in a VPC. So it's like having a server. But also because so you don't have a server to patch, you have AWS that protects you, you can put a WAF, you can put something in front of it, but I mean, it's not like a data center on which you have the perimeter, you have the load balancer, you have the firewalls, etc. So here, in this environment, you lose the perimeter. The perimeter is identity, so it's completely different. WAF, many times, we have seen is not enough, can be bypassed. So it's there are many aspects that I think still need to be digested by the experts, by the engineers, by the architects, also in security teams, to reach the right level of security. So it's increasingly, I think there will be much more in the future as soon as the application move to that architecture.
Yeah, I can see that a lot of people are focusing more on identity, as you said, as it is becoming the perimeter. And like I've always thought, like, hey, you should start right there, and so that's a good idea. So I'm glad that it's starting to gain more focus as people are moving to the cloud as well. Okay. So then, other than this like serverless top 10, where do you go to find out more information about serverless security for those people who are watching who are like newer to the industry or just trying to find more resources? What would you suggest for them?
Well, there are not so many resources. So
Hmm.
um, when even before joining Contrast and doing research, so I was looking for resources to learn about serverless security, and there is not so much resources. So I
Hmm.
think there are 2 books for serverless security.
Yep.
Uh, um, and some blogs. So my suggestion is to look at that books. I think are from, if I'm not wrong, from Pact Publishing, um, and look for blogs and articles in internet. So I'm looking to start my personal blog. So probably I hope I will be a contributor of this, increasing the awareness for this field. But there is not too many resources on this.
Yeah, it's still pretty new.
Fortunately, yeah.
Yeah. Okay, awesome. Anything else? I think most people are just sort of like eating dinner or whatever, but there's no questions from the audience. Is there anything else you'd like to say to the audience? Do you have any questions for like me or for Adam had to leave, so
Again, I they invite to reach out to me if someone have any question, if you have any suggestion, if you have any critic on the presentation, obviously, and if I will be more than happy to receive data for the top 10 OWASP projects for serverless, and also for CodeSec by contrast, the free tool, because we really want to give value to developers. So, and shifting left the scan and the security work for developers. We want to make their life easier because we are aware it's tough. It's not an easy thing. So every type of feedback, please send to me, because we really need feedback in this field.
yeah, especially when it's developing. I agree. Okay. Well, thank you again for all of your time for the great presentation. Always interested to get different people's take on the serverless top 10 and like the other top 10 kind of like lists. So thank you for the, very thorough covering of the top 10 and then also the little tidbits on the other kinds of vulnerabilities to look out for. Appreciate your time, Paulo.
Thank you. Have a nice evening.
Have a great evening. Okay. Bye. Bye, everyone. Thanks for coming. Please come back for the August presentation as well. We'll see you in about a month. Bye.
Bye.